Hi, good morning students. So my name is Simran. So I'm here to explain you about the topic that is the linear algebra. As you can figure it out, this is the most important topic in our engineering mathematics. To start with the linear equations, I hope you have done the linear equations in your previous classes also. But now we will be applying those linear equations in the advanced maths and you will be solving a new topic that is the linear algebra. So what is the basic concept of the linear algebra? To solve system of linear equations. Now, in today's modern world, whatever the type of data that you are watching it up right now, if you want to analyze or if you want to clean, if you want to structure, we need the basic concept of the linear algebra. So this is the advanced application that whatever you will be theoretically doing in the class, you will be practically applying in the engineering part in the various departments like data analysis, machine learning, and these types of the basic concept is required for you. Now, in this class, we will be discussing with the rank of the matrix and the echelon form. To start with the rank of the matrix and echelon form, you must be aware of the matrix, that what do you mean by the term matrix and how do you define it. Let's just see in this class. Matrix is a rectangular array representation of an elements with horizontal lines are called as your rows and vertical lines are called as your column, right? Okay. Now, if you have from this picturization, it depicts that you have 3 horizontal rows and you have 3 columns. So the order of this matrix would be, I hope you are all aware, that is m cross n, which is 3 cross 3 matrix, right? Now, we have defined that this is a matrix. Now, since you have done your linear equations in your previous classes, in your lower classes, you must have seen that there are certain equations. Let's suppose this is an equation which is a linear equation in 2 variables that is defined in such a way. Now, you have found out the solution for these equations for the value x and y in your small classes. But now when you are moving on toward the advanced part, you will be make sure that when you will have large number of equations, for example 1000, 10,000, large number of equations, then how do you need to solve the values for x and y? Linear algebra will help you. So this is the practical application that we will be performing in the further classes. But if we wanted to compute this linear equation into a representation form, that is would be called a matrix form. Now this is here in this class we are dealing with only 2 equations. We can represent in these 2 equations in the matrix part in such a way: coefficient of x is 1, coefficient of y is 2, coefficient of x is 1, coefficient of y is 2. So this linear equation in 2 variables which are 2 in number can be represented in 2 cross 2 matrix. Now, but if I have large number of equations, how you can compute? You can take help from the linear algebra topic, that is the matrix representation, right? Now, this was all the basic concept that we have discussed it right now. In this class, we will be discussing with the topic that is the rank of matrix. Now, to start with the rank of matrix, you must be aware of the 2 parts, that is the determinant and elementary transformation. Now, in your previous classes, in your small classes, you might have done the determinant. You are already aware that how do you perform the determinant. If I say for the 2 cross 2 part, you will say similarly that is AD minus BC. If I say for the 3 cross 3 part, you have 3 rows, 3 columns, you will apply the traditional method. That is A, E, F, G, H minus B, similarly plus C, like this. So this is the traditional method, you might are already aware. But if we want to find the rank of the matrix, first of all we must be aware of the definition also. To start with the definition, rank of matrix is defined in such a way that if a matrix has number of rows, that is 3, number of columns is 3, to depict that what will be the rank of matrix, you will be finding out the number of linearly independent rows or columns. So what is the definition? How will you say that what will be the rank? You will check out, first find out the matrix. When you will be finding out the matrix, from that matrix matrix, you will be checking out that how many linearly independent rows are there. Okay. After that, or it could be deal with the column also, not an issue. Either you can choose rows, either you can choose column. Now, to define a rank of matrix is defined as the number of linearly independent rows or columns in the matrix, and it represents the dimensionality of the vector space spanned by the rows or column of the matrix. But in this class, we will be moving on with the rank part. So we will be figuring it out that how you can say, if you have an equation, let us suppose we consider this example. If I say 1 0 1 0 1 0 0 0 1, let us suppose if this is your example. Now you can see this is an identity matrix which is of 3 cross 3 order. And can you just find out that how many linearly independent rows are there? Linearly independent rows means that there is no dependency relation you can see in any kind of matrix. Now you can see that from the row 1 you have the first element as 1, in the row 2 you have the second element as 1, and in the row 3 you have the third element as 1. Now A11 is 1, A22 is 1, A33 is 1. Right? From this matrix you can see that number of linearly independent, how many rows we have? That are 3. So the rank will automatically, you will call out to be 3. Fine. But if I say you need to find out the rank with the help of determinant method, what would be the determinant of this identity matrix? That is, apply the same traditional method. That will be 1. So now, what does it say? That if the value of the determinant is non-zero for that particular order, that will be the rank of matrix. This is the determinant method by which you can find out the rank. Now, there is one important point. If I say your determinant is non-zero, what does this mean? That this is a non-singular matrix. If I say you have the value of determinant as 0, this is called to be a singular matrix. So these are some important terms that are used in your course. So please make sure that you must be aware of it. Now, after the completion of singular matrix and non-singular matrix, this was the case for the very basic part, identity matrix. Now, if I take one case of one example, that is 1 2 3 0 1 0 0 0 0. Now, as you can see, how many number of linearly independent rows you can see here in this matrix? Okay, first of all, what is the order? 3 cross 3, 3 rows and 3 columns. But now, apart from that, to calculate the rank, if I generally want to see the straightaway method, you will just find out the number of linearly independent rows, which are how many? 2. Therefore, rank of this matrix will be 2. But if I want to choose with the determinant method, you will apply the determinant. Now, since you will be applying the determinant on 3 cross 3 matrix, what you will be getting out? You will be getting the value of determinant to be 0. Now, this says that for the rank of matrix, if the value of the determinant comes out to be 0, then you will be checking the another minor, which will be in the format in such a way that if 3 cross 3 matrix is giving out to be determinant 0, you will choose any sub-matrix from that particular matrix, but it should be less than 3. So if I choose this matrix, any sub-matrix it could be. If I choose 1 2 0 1. So this is the sub-matrix of this particular matrix which I have chosen, that is 1 2 0 1 as its element. Now if I found out the determinant for this will give you the value non-zero. Hence, you can say that the rank would be 2 here. Now I have already told you 2 methods. One would be the number of linearly independent rows, that is the straightaway point, and another is with the help of determinant method. If I club all these points and give you the summary about it, for the determinant part, you will always make sure that if the determinant value is non-zero for that particular order, that will be a rank. If it is coming out to be 0, then you will be choosing a sub-matrix from that particular matrix and you will be checking out the determinant. If it comes to be non-zero, then that would be a rank. And if again it is coming out to be a 0, then you will again choosing coming up with the smaller submatrix of that particular part, and you will be coming out with the rank. That was all with the help of the determinant part. Now, if I say you have one matrix, let's take this case. Okay. Now, in this case, you have 3 rows and 3 columns. Fine. So, the step number 1 that you have to choose out is you will be calculating the determinant. So, there are innumerable number of methods to find the determinant. You can use the short trick also, but if I use the traditional method, we will apply in such a manner. So, you will be getting the determinant 0 here. Okay. Now, I have already told you, if you are getting the value of determinant to be 0, you will be moving on with the submatrix of that particular matrix A. Now you can figure it out. This is the particular matrix A. You will be choosing the submatrix in such a way that the determinant of that particular matrix should come out to be non-zero. If I choose this matrix, let us suppose 4, 6, 7, 9. Okay. Now, when I found out the determinant, what I got the value? 36 minus 42. So, this is a non-zero number. So, that means the value that the rank of this particular matrix will be 2. Because we have found out this submatrix which is of 2 cross 2 order, which is giving out the value non-zero. Hence, rank would be 2. Apart from that, if you wanted to go with the straightaway question, you can see that these are the numbers which are having some dependency relation. In the first part only, I have already told you that for the rank, you need to calculate the number of linearly independent rows or columns. So from that part, you have got the value that rank could not be 3, it should be less than 3. One more important point that you have to keep it in mind, that the rank will never exceed the order. It can be either less than the order or equal to, but it will never exceed it. The second result, which is the most important result, is that if a matrix has a non-zero minor of order R, therefore its rank would be greater than equal to R. Then the second result, what does it say? That if all minors of the matrix of order R plus 1 are 0, then its rank would be less than equal to 3. Therefore, most important point, you might be aware of this part. This is for your representation for the rank, which I have told you that the rank is represented in such a way, that is row, comma, bracket, parenthesis A, parenthesis over. Now, coming up with the next part, that you need to be very careful about the properties that I am going to discuss it right now for the rank. To start with the property, if I say you have been given with the matrix A, the first property that you need to keep it in mind, if I say you have been given with the matrix A, which is of 3 cross 3 order, and if I do the transpose, okay, what does the transpose means? Row becomes column, column becomes row. So, rank of A will always be equal to rank of A transpose. Okay, this is one of the properties that we have to discuss it right now. And now, coming up with another property, if I say you have 2 matrices, and if I do the product of these 2 matrices, the product of the 2 matrices, when I am doing it up and finding out the rank, it will never exceed the value of rank of A and rank of B. Fine. So now we have discussed that to start with the rank of A, you must be aware it should have number of linearly independent rows and columns, and the determinant value should not be 0, it should be non-zero. And after that, the rank of matrix is the largest order of any non-vanishing minor of the matrix. Why so? Because whatever the matrix that you will be choosing, if the determinant is coming out to be 0, then you need to look out for the another submatrix, and if that submatrix is giving you the value of the determinant to be non-zero, then that order will be your particular rank. So this was all the theoretical concept that you need to apply to solve the rank. Now the basic and the most important point that we need to find out the rank is with the help of the elementary transformation. To start with the elementary transformation, must be aware that how do we deal with the matrix addition and how do we deal with the matrix subtraction and how do we deal with the matrix scalar multiplication. Now, to start with the elementary transformation, you must be doing the elementary transformation in such a way so that you could find out the rank. Now, let's take one example. Yeah, here we have the example. Now, okay. So we have one example, that is 1, 2, 3, 1, 4, 2, 2, 6, 5. If I need to find out the rank of this metric, first of all I must be aware that what is its order. Now you can figure it out that its order is 3, 3. As you can see, we have 3 rows and 3 columns, right? Now, the first point that you need to keep it in mind is the first element. That means the first row element, first column element. It should always be 1. Then, if I say these are the elements that I have given to you. Now, after the 1, you will be making down all the elements 0. Then, when you have chosen the elements that is A22, A21, A31 to be 0, then you will be moving on with the next part, that is the A22 element. You will be making this element to be 1, and in the preceding part you will be making this element to be 0. Now, whatever the operation, whatever the symbolic representation I am giving it to you is, you will be applying those symbolic representation with the help of elementary transformation. Now, to start with the elementary transformation, if I say the very first step, as you can see, is step number 1 in this part. In this metric, first element is already 1, therefore we are already on the safer side. But I had already told you, when you are choosing the element to be 1 on the first side, after the element 1, in the preceding part you will be make down A21, A22 to be A31 to be 0. To make A21 and A31 to be 0, you will be applying the elementary transformation, that is in such a way. I would recommend you, that is R2 implies R2 minus R1 and R3 implies R3 minus 2 times R1. Now, when you are doing and applying these operations on that particular matrix, please make sure about that particular thing. You will be applying these operations on the first part, and after the step number 2 will be coming, you will be applying those operations on the step number 1 matrix, right? Now, to start with this, when I say R2 minus R1, first row element will be already same in the same manner. Then you will be getting 0. 4 minus 2, 2. 2 minus 3 is negative 1. Then 2 minus twice of R1 will give you 0. Then 6 minus 4 will give you 2. Similarly, 5 minus 6 will give you negative 1. Right? So this is the step number 1 that we have already done. After you have chosen the A21 and A31 to be 0, you will be moving on with the second part, that is you have to make A22 element 1. How are you going to make that A22 element 1? You can just apply the operation in such a way, that is R2 implies half times R2. Now, what are the elements you will be choosing? You will be getting them 0, 1, negative half. Okay? You will be doing the same operation here. Now, please make sure about that particular thing, that whatever the operation you are applying in the step number 2, whatever the elementary transformation you are doing it here, you must do it on the step number 1. In the same ascending manner you will be doing it, right? Progressive chalna. Uske baad in the step number 3, you have found out that your A22 element is 1. Now, after A22 elements, you have to go down and make this element 0. How you could make that this element to be 0? By applying the operation R3 implies R3 minus twice times of R2. Okay? Now when you will be doing this here, 0, 1 minus half as it is, 0, 2 minus 2 times of R2, that is 2 minus 2 will give you 0. Similarly, minus 1 twice of minus half, which will give you minus 1 plus 1, which will again give you 0. So now these are the steps that you have done it right now. The ones which are doing it, the elementary transformation you are observing here, these are the transformations which will help you to find out the rank of a particular matrix. Now, in the step number 3, you can find out that how many number of non-zero rows you can see. 1, 2. Therefore, we have another definition for rank, that number of non-zero rows will also give you the rank of matrix. So how many number of non-zero rows you can see? We have 2 number of non-zero rows. So that means rank of A will be equal to 2. So this was the very basic steps that we have applied, but we had applied these rank operation, rank just to find out the rank in the row operation. Similarly, you can choose the column operation also, but please make sure about that particular thing. While doing the elementary transformation to finding out the rank, either you can apply row transformation once or either you can apply column transformation, but you can't combine both of them. When you are done with this part, you have got out the value for rank of A to be 2. What does this matrix says to us? That if the value of this particular matrix gives us the rank to be 2, then it says that this matrix can be transformed into this form, in which this is called your normal form. Now in the normal form, we always first find out the rank and then we make sure that whatever the particular matrix has been given to us, we must convert that particular matrix into identity matrix, right? Now, if this particular matrix is giving us to be the rank 2, we must be aware that the normal form of this particular matrix will be in the order this. Okay? Now, but to make this matrix into this form, into the normal form, you can apply row plus column operation both. So right now, we will be moving on with the next part, that is the echelon form, in which you will be make sure that whatever the operations that we have discussed it right now, in the same elementary transformation you will be applying on the given part to find out that what will be the row echelon form. Now to start with the row echelon form, you must have seen the properties here. Now it is a method to provide a standardized way to represent a matrix, and it simplifies the process of solving linear equation and analyzing the system of equations. But each and every row of matrix, all its entries are 0 and occurs below every row which has a non-zero entry. Now I have already given you one example. You have seen that this is a matrix with elements -1, 3, -2, 6, 0, 1, 7, 0, 0, 0, 1, 3, 0, 0, 0, 0. Now, the first part that it says that the every row of A which has all its entries 0 occurs below every row which has a non-zero entry. From the first part you can see this is a non-zero row, and after the non-zero row we have the 0 row, and after the 0 row we have the second element to be 1, and in that part the third row will be in this manner. Similarly in the fourth row will be in this manner, right? Now coming up with the second property, it says that number of 0 preceding the first non-zero element in a row is less than the number of such zeros in the succeeding part. What it is trying to say that if you have a matrix in this part like this, now this was the first row which has the first element to be 1. After the 1, we are already aware you need to make all these entries to be 0. These already are done. Now, in the second row, after doing all these entries to be 0 by elementary transformation, we will be moving on with this part. So similarly, if I want to explain it in a symbolic manner, you can choose in such a way that if this element is 1, let me just do it some another pen. If this element is already chosen to be 1, you will be applying the row operations in such a way you will be doing 0, 0, 0 by the elementary transformations. After that you will be move towards this part, which is you will make this element to be 1. Then its preceding elements will be 0, 0, and after that you will be choosing A33 element to be 1 and its preceding elements to be 0. So you want to apply the row operation in such a way so that you could get a pattern in this manner. If you are getting a pattern in this manner, it will be very easier for you to look out for the rank, right? Now you can see these are the properties of the echelon form, which says that the leading non-zero entries has a pivot element which is strictly to the right of the pivot in the row above. So the strictly right means that this first element should always be 1. And the second property it says that zeros rows if they are located at the bottom of the matrix. Similarly, what it is saying that if the first row is 0, first element of this first row is 1, then its preceding element must be 0, right? And then the third part it says that linear independence, rows with the leading non-zero entries are linearly independent, forming a basis to the row space. So in the upcoming part, when you will be making down the matrix and you will be choosing down the row elements, you will be getting down in the specific pattern and you will be observing certain kind of operations which are the new advanced properties for the bases and dimensions also. Now, if I choose this question, in the previous part also we have discussed it right now. Let me first choose one question for you. Yeah. So if I choose this question, that is negative 1, 2, 3, negative 2, 4, negative 1, negative 1, 2, 7. Now as you can see, you have 3 rows, 3 columns, and you need to reduce this matrix into the echelon form, or you can say you can reduce it into the normal form. First of all, you will apply the same properties. What you are going to do is you will be making sure that about particular thing you will be applying that first element should be 1. It should neither be negative, it should neither be positive. It should always be 1 here. Now when you are saying that row 1 should be 1 here, you have to make that particular element 1. Now when you are applying these properties, you need to apply in such a way you can do in such a manner, that is R1 implies R1 minus R2, right? When you will be doing this property, what you will be getting? Minus 1 minus of 2, which will give you minus 1, which will be 1. Similarly, here what you are going to get is negative 2, then you are going to get is 4, then negative 2, 4, negative 1, negative 1, 2, 7. So when you will be applying the operation, you will be getting down the matrix in such a way. This is your first part. After the first part, you have already found out that the leading entry is 1. Now when you have already found out that leading entry is 1, you need to make sure that its preceding element, its downward element should be 0. And how are you going to make the downward element 0? By the operation R2 implies R2 plus twice of R1. Then you are going to do is 1, negative 1, 4, negative 2 plus 2, which will give you 0. Similarly, 4 plus 4 will give you again 8. Negative 1 plus 8 will give you 7. Similarly, when you will be doing with the row 3 operation, you will be applying row 3 in such a way, that is R3 plus R1. Now negative 1 plus negative 1 will give you 0. 2 minus 2 will give you again 0. And this is 7. 7 minus 4 will give you, 7 plus 4 will give you what number? That is 11. Now in the same manner you will be moving on with this part. You will make sure that this particular element should be 1 and its downward element should be 0. Now when you are doing this, you will be make sure that about this rank will be coming out to be 3. Now when you have seen that there are number of non-zero rows are 3, which will give you the value of 3 here, that will be coming out to be the rank here. But after the rank, if we want to convert this matrix into the normal form, we will be applying row operations and column operations in such a way that you must get a matrix in such a manner, that is identity matrix, which is of 3 cross 3 order. So these are the types of the row operation that you will be doing up here. make sure about that particular thing, that when you are finding out the rank of a particular matrix with the help of determinant, you will be applying the same concept, that the determinant should be non-zero. If the value of determinant is non-zero for that particular order, that will be a rank. But if it is coming out to be zero, you will choose the submatrix. First point. Second point is, if you are applying the elementary transformation to find out the rank, you will be only applying the row operations. But if you need to transform that matrix into the normal form, then you can apply row plus column. So these are the operations that you have to apply. Please make sure that rank and echelon form have the same properties. Only and only you need to apply elementary transformations of row or column individually into the rank part. But if we are going on with the normal form, you can apply row and column operations both in that particular matrix. So that was the concept. In today's class we have discussed about the rank. I have already told you the summary. Now as you can see, the application of the echelon form, you can already choose that echelon form to solve multiple linear equations, and you can do some matrix analysis also. Apart from that, you had some basic knowledge about the applications of linear algebra, which you will be using in the upcoming part, and you will be applying in the machine learning and computer graphics and data analysis. So that was all for today's class. So thank you so much. Wish you the best.